Let's take a look at arc length. The radian measure of an angle theta is a ratio of the length of the arc it spans on a circle S to the length of the radius of that circle R. So this is like saying the measurement of an angle in radians is the number of radii that could fit into the corresponding arc length. We write this equation as theta equals S over R. Now we can rearrange or solve this equation for the arc length and get the equation S equals R times theta. For this equation, we need a couple things. We need the arc length and radius. Those need to have the same units, and the angle measurements needs to be in radians. Let's look at an example using this equation. How far does the tip of a minute hand of a clock move in 35 minutes if the hand is 6 inches long? So I think it's a good idea to draw a picture here of a clock. Okay, we know that the 12 is up there, and for 35 minutes, then let's see, the minute hand would start at the 12 and then end here. So it's like we have the initial side and the terminal side. The initial side starts at the 12, and then the terminal side here is at 7. And so this creates an arc length on our circle here. And so I'm going to start by writing this equation again. And we're trying to solve for that length. So it says, how far does the tip of the minute hand of the clock move? So that is the arc length, meaning like if I was a bug and I was just walking on the part that the tip goes past. So here I am being a little bug, okay? And I'm kind of walking along. How far is that path? And again, we're starting at the 12, but ending up at the 7. Well, the radius is just the length of that minute hand, and that's 6 inches. Okay. And then I'm going to multiply that by the angle. Well, what angle is this? Well, we can kind of think of it in terms of some fraction of a full rotation. So I know in radians, because this angle has to be in radians, a full rotation is 2 pi. And I know that a clock, I can think of it as being broken up into these kind of 12 little segments. And if I'm using up 7/12 of those in my rotation, then I can just write it like this. Okay? So what would that look like? Well, what are my units going to be on this? Well, I know that the radians I really think of as unitless. And so this radius here and the arc length are going to have the same units. So how far does it travel is going to be in inches. And then when I look at this, I get, let's see, 6 times 7 times 2 times pi are going to be in the numerator, and then just the 12 in the denominator. Doing some nice canceling when it's still in this form gives me 7 pi inches. Now, that's a little bit confusing because it's hard to picture what that's going to be. So I can just take over my calculator here and do 7 pi. That gives me 21.99, or about 22 inches is how far the tip of that minute hand travels.